Starting the recording now. We are going to our discussion today. Here
Sir, you
is,
repaired your laptop?
yeah, this one is my one. I am showing you my one.
Okay.
Yesterday I could manage it to go there. The school opening day is not possible to go.
Yes.
Then yesterday I got the chance and I
Sir,
went and received it.
yesterday was an off day, so you got
Yeah.
chance.
Sir, my office in the waiting room.
So in last class we got Newton's first law. Okay. Now I will randomly ask anyone about Newton's first law. They who are attending in class, you all get ready with your notes.
Okay.
It's written in your notes. Who I will tell you, then you will answer. Okay, everyone keep your microphone on. Okay, Tazrila, from the day one, I don't get your microphone. Only a single day I got your microphone. Other days, no. Tazrila, hello Tazrila. If you are attending class, you should be equipped with your all the instruments and get ready for taking part in the discussion, right? Yeah. So Lamisa, can you tell me Newton's first law?
Newton's first law. Okay, wait.
Yeah. Tell me
Newton's first
Newton's.
law, right?
Yes, right. Tell me, please.
First law. Newton's first law of motion states that a body will continue in its state of rest or uniform motion in a straight line unless an internal resultant force acts on it.
Yeah.
It means
So,
an object will move on a straight line
external.
unless a force acts on it.
so it is related to balanced force, right?
Yes, sir.
Newton's first law is related to balanced force. Balanced force means there is no resultant force. Your forward force and backward force are equal, isn't it? Hello?
Yes, sir.
And you are getting two conditions or two situations in Newton's first law. In one situation, the object is in rest, and another situation, the object is moving at constant speed. Not only moving, it's moving at constant speed.
Moving in a straight line.
Yeah, so these things you should have in your mind always, that in Newton's first law we are getting balanced forces. We are having two situations. One is the object can be in rest or the object can be in motion at constant speed. When the object will be in rest, if the object was in rest from before, like you are sitting in one place, and that moment your resultant force, the weight and the contact force from the chair is coming from chair, that is balanced, right? So you are in rest, isn't it? Any object, my mobile phone I kept in one place, so the resultant force is zero, right? Newton's first law, isn't it?
Yes.
Sir.
And the car, which one is going with constant speed on a road, that is also Newton's
First law.
first law. At constant speed the object is moving.
Oh.
The skydiver falling from the sky, his weight and air resistance are equal and opposite. He is in terminal speed. That is also Newton's first law.
First
Newton's first law.
law.
Is it clear now, everyone?
Yes.
So,
I didn't understand.
Hmm?
which one you did not understand?
Newton's first law. Sorry, third. This one, sir. Third law of motion.
Did I discuss third law yet?
Sir is telling
Oh.
first law.
The first law we
Oh.
already did. That one we are discussing. And that is only revising, right? Because
Yes.
we should have some revision. If I straight go to new thing, then they who are absent in last class, they will not get it. Everything will go above their head, and they who did not revise also you might forget, right?
Yes, sir.
That's why I am revising it so that you can get onto your toes. Are you clear?
Can you explain again?
Which one?
Just
Skydiver one. That skydiver one.
Yes, sir.
yes, sir.
Okay. Skydiver, when he is in terminal speed, you all know that skydiver has weight downwards, isn't it?
Yes.
Yes, sir.
And air resistance is working upwards when he is falling, isn't it?
Yes, air resistance opposites.
Yeah, so when air resistance and weight are equal, then there is balanced force, right?
Yes.
So if it is balanced force, there is no acceleration, but the skydiver is not stopped. He is still falling, right?
Yes.
So he is falling with constant speed. Is it clear now?
Yes, sir. Now clear.
Okay, if it is now clear, then write it. Write this note.
Okay, sir.
You write here.
Sir, can you also write it in the screen?
Yeah, I'm writing. Write this way. It is skydiver, right? Label this one as skydiver. Okay. Then the weight is working downwards,
Yes.
and air resistance is working upwards.
Upwards.
Yeah. And this is balance force, right? I'm writing all of them, then you'll understand. Here is air resistance. Look, when I gave the arrows upwards and downwards, I tried to make the arrows equal length. That shows that forces are equal. Air resistance. Done. Then weight. Then
Skydiver.
skydiver. Right here,
Then skydiver.
skydiver. Label this one as skydiver. This person is skydiver. I'm not drawing the skydiver. I'm just showing you.
His box is skydiver.
Okay, now here we are getting balance forces, right? Another Anmol. Another Anmol is there.
Yes,
There
sir.
is only
That's
one
me, sir.
That's you. So why
Yes,
not
sir.
you are informing me before coming?
Sir, you were explaining, sir, so I thought not to interrupt.
Okay, okay. Balance forces, acceleration 0. Okay, write it. Acceleration 0. Then
The speed will be constant, right?
travels at constant speed. And this speed has a particular name. Constant speed, we tell it terminal speed, right? Can you remember?
Yes.
In last topic also we had this terminal speed.
Yes. Sir, like terminal speed, terminal velocity, all this.
Yeah, terminal speed is constant speed, okay? And this example is related to Newton's
First law.
first law. Newton's first law. So they who were absent at the beginning, you did not join at the beginning. For them, one information I am repeating, they who were present at the beginning, I shared with them. Today is Wednesday. Next Wednesday, there will be test on this topic. Topic 3, dynamics. Whatever we can finish on that part only, we will have the test.
So there will be a revision. Oh shit.
Revision will be done by you. Okay, the recordings are there. Today I will upload the recording.
Sir, you will give worksheet.
And previous recordings are with you. Worksheet, if possible, I give you. Otherwise, you have to take preparation on the notes. Okay? Is it clear?
Yes, sir.
Okay, now we have done with first law. Newton's first law is done, right? We have another law related to balanced forces.
Sir, can I say something?
Sure.
Yes.
On
Sure.
behalf of Advita, she has some connection problems, so she will leave and join again. Can you let her in?
Yes, sure. Sure, no problem. Ryan. One is Ryan Reed, another one is Ryan.
Yes.
And what is his full name? Ryan's?
So, but he's not a physics student, sir.
So why did he come, this Ryan? Can you
Sir,
see in
don't
the
allow.
list?
Sir, you can ask him why.
Ryan, he left.
Just came to see what we are doing.
Okay. So people are playing, huh?
Yeah.
Okay. They don't have any scope to play other place. They came here to play. Okay, now Newton's third law. What I was saying about Newton's third law, can you tell me again? What did I say?
Sir, you told Newton's first law.
Newton's first law I said, then I was starting third law and I was saying something. Can you remember that or what I said? I said that Newton's first law is balance
You
force.
said there is another.
Yeah. So I said Newton's first law is related to balanced force, right?
Yes.
Then Newton's third law is also related to balanced force. Is it clear?
Sir, we will give the test on practical, sir.
Yes, sir.
Wednesday.
I will tell you. And now what I said, you just follow that. I said you will have test on Wednesday on topic 3 only. Okay? Is it clear now? Practical test, I will let you know. I will give you at least 1 week. Before taking any test, I will try to give you at least 1 week so that you can have preparation. Is it clear?
Okay, sir.
And this note I uploaded many days back. They who are interested to learn, they who are really, serious about their studies, I think they already finished reading it, the notes. And some of you are there, we need to push you from your backwards, that you read, you learn. Am I right? So it's your decision now. Uh, will you be spontaneous, self-motivated, or you
Yes.
have to push? You should have some push
Self-motivated.
from backwards. What you prefer, that's your choice now. Okay, now
Self-motivated.
everything is with you. You can get it or you can avoid it. Now, Newton's third law of motion, I said that this is also related to balanced force. Balanced force means the forces will
The
be,
opposing reaction forces are equal.
yeah, forces will cancel each other, right? That is called balanced force. Now, here we are having one example. Look, the person is pushing the wall, his finger against the wall, and the wall is also giving equal and opposite force on his finger. Is it clear to you? You can test it today. Today you push the wall with your finger, then you will understand that,
Sir, I will get hurt if I
yeah,
It
do.
won't
you get
budge.
hurt. You get hurt, right? Now you can try on your table. On your table you can try. Are you trying?
It won't budge.
Yeah. So this
No,
one is
I think my
giving you,
fingers are fragile.
Yes, sir.
yeah,
It's hard, sir.
yeah, it's
Sir,
hard. So your table is giving you one
Push
opposite
back.
force
Yes,
on
opposite
your
force.
finger. Yeah,
Yes.
Anmol Hussain, thank you for raising
This
hand.
is,
Tell
sir.
me.
This is called Newton's third law of motion, right?
Hmm. Anmol,
sir.
yes,
So, sir, when we walk on a floor, sir, the floor also gives a
yes,
force
yes,
against
yes.
Good,
Awesome.
Anmol. Good.
Yes, your answer, your example
That's
is
also
correct.
Newton's third law of motion.
So in our real life example, we get these third law examples in many places. I will let you know more examples. Okay.
Like
Now
we see,
listen. Before you're talking, you should raise your hand. Look, what's written here? Lamisa, can you read, please?
sir.
Newton's
Newton's,
third law.
Newton's third law of motion. Newton's third law states that if body A exerts a force on body B, then body B exerts a force of equal magnitude, but in the opposite direction of body A. Forces always occurs in pairs: action force and reaction force. Action and reaction forces. Some properties and action of the action and reaction forces are as follows. The action and reaction forces are equal in magnitude. The action and reaction forces act opposite to one another. The action and reaction forces act on different bodies.
Okay, okay. Thank you so much.
Welcome, sir.
Okay. Look here, it's very important here now. You should write the law, write the heading Newton's third law of motion. Yeah. Then you write till here you write. Okay, till here you write action force and reaction force. Then you write this. The action and reaction forces act on different bodies. In Newton's first law, look, skydiver. It is only one body, right? Hello, only one object,
Person.
skydiver. The
Yes.
forces are working on the single object. This is
Yes, sir.
Newton's first law. But Newton's third law, force we are getting on different bodies, right? Your
Yes,
hand
sir.
is one body and wall is another body. Two forces are working from two bodies. And here two forces are working on one body. You should remember it, you should memorize it, and don't mix up.
Okay, sir.
Please take these notes. Whatever I'm saying, I'm not saying a single comma extra. You should take them, write them, and learn them.
Sir, I've written it.
Yeah, very good. If you are
I
done, then,
also written it.
yeah, if you are done, then tell me, all of you.
Okay, sir.
Sir, I'm done writing.
Yeah.
Sir, will
Okay.
you write this?
You did not write?
Yes, no. I didn't hear you.
Yeah,
Couldn't
yeah,
hear you actually.
yeah. Write it quickly. Newton's third law of motion, you write it quickly. And this point, that one I marked with red. Quickly write. So let them write, and we are going to have discussion here, like unbalanced force. Where it is called balanced force, you understood. That means all the forces cancel each other, right?
Yes, the resultant is 0.
Yeah, resultant is 0. But in unbalanced force, one force will be bigger, another force will
Than the
be
other.
smaller. So if you do the sum, then you will get some part extra, right? Like if it
Yes.
is
One arrow is
5
bigger.
Newton, if it is Batsha, why you want the sharing of screen? Batsha?
So, me.
Yeah, Batsha
Oh,
first.
sorry. Maybe I send you the request for remote control.
Why? Why
Sorry,
need
sir,
that?
by mistake. Sorry.
And it is making problem. Look, I have to now again go to annotations, then I have to find it. It's making a problem. You should be very careful. If you are
Yes, sir.
saying sorry,
Sir,
that time will not come back. Already 1 minute, 2 minutes lost. 5 Newton minus 2 Newton. Your resultant is how much?
3 Newton.
Resultant coming
3
3
Newton.
Newton. 3 Newtons. So resultant is 3 Newton. So we are getting here resultant force. Is it clear?
Yes, sir.
Yes.
And the resultant we can represent this way. It's working right side, and the size of the force is like that. If it is 5 Newton, it is 2 Newton, the 3 Newton will be like that.
Sir, Newton's third law, like the writing is finished. Will I write that 2 Newton and 5 Newton?
Sorry?
Will I draw the 2n and 5n?
Yes, in unbalanced force, you write this. We are going to discuss now unbalanced force. You write it there, okay? After writing unbalanced force, you write this example. Then you write this statement.
Finished.
Please do it. We already got Newton's.
Yes, sir.
We already got Newton's first law and third law, right?
Yes, sir.
So are you writing unbalanced force?
Yes, sir.
Yes, sir.
After writing
Yes,
unbalanced force, you draw this 2 Newton, 5 Newton, then resultant.
Okay, sir.
Then you write this statement: when two or more external forces acting on a body produce a net resultant force, that is the vector sum of the forces is not zero. The forces are unbalanced. This one you
Okay,
write.
sir.
So I told you we already got two laws, first law and third law on balanced forces.
Yes.
Right? Now we are
Yes, sir.
getting unbalanced force, that is only for second law,
Second law.
Newton's second law. So when we are getting resultant force, there will be acceleration.
Yes.
The object will move forward with acceleration. Is it clear?
Yes, sir.
Okay, so Newton's first law is related to unbalanced force, balanced force. The third law is related to balanced force, and second law is related to unbalanced force. This one you have to remember always. Okay,
Okay, sir.
now Newton's second law. Newton's second law for unbalanced force. Here you go.
I finished.
Yeah, you finished till this one. The forces are unbalanced, right?
Yes.
Sir.
Then you write now Newton's second law of motion. Newton's second law of motion says that the resultant force acting on an object, on a body, produces a net acceleration and causes the body to accelerate in the direction of the resultant force. Very important to understand. Look, he said
Sir, I do
acceleration,
not need to write this. It's written in the notes.
you should write it. I did
If you
not say
write it,
to
it will
write
stay in your
everything.
mind for longer.
I did not say to write everything. Whatever I am
Yes,
saying
sir.
to write, you should write that.
I just asked it.
Okay,
You know.
okay. And after writing that, you write this formula. Okay? This formula you have to
I
write.
wrote.
And did you underline this? To
Yes, sir.
accelerate in the direction of the resultant force. That means acceleration and resultant force will be in the same direction. Very
Oh,
important. Very, very important. It's very, very important. That's why I underlined it. You should understand it, because if you don't understand it, you will not understand the things coming forward. Look here, F equals ma. F equals
Mm.
ma. M for
passive.
mass, A
A
for
for acceleration.
acceleration. If there is zero acceleration, then force is zero, right?
Yes.
Yes.
So what does it mean?
It means the object is stationary.
Yeah, the object, if it is,
It's stationary or it is in
yeah,
the terminal velocity.
if the force is zero, resultant force is zero, acceleration is zero also, right? Isn't it? If force is zero,
Yes, sir.
acceleration will be zero.
Acceleration
That
is
means
0.
the object will not have any increase in its speed. Speed will be constant, or the object will be in rest.
Yes.
So this formula is also, though this formula is related to second law of motion, but it's also helping us to understand first law. Is it clear? Numerically, we can,
Yes, sir.
numerically, by giving the input, we can understand, clarify Newton's first law as well. Okay?
Yes, sir.
Is it done, everyone?
Sir, can you
Yes, sir.
explain
Almost.
again, sir?
Yeah, I am explaining, no problem. Look, if you think the resultant force is 0, then your acceleration is 0, right?
Yes.
Because m is constant, mass is always constant. So if your force is 0, that means your forces are balanced, you have no resultant force, then there will be no acceleration. Is it clear?
Yes, sir.
Yeah. So if there is no acceleration, that means either the object is stationary or the object is going with constant speed. Is it clear now, Anmol? Hello?
Sir, not yet, sir. A bit confusion is there.
Tell me your confusion. What confusion?
About the force and acceleration you just told.
If you write here in the place of force 0, then acceleration will be 0, right? Because 0 by m is also
Existent mass, right?
0 by m is also, if you
0.
Zero.
calculate, it will be 0, right? So
Yeah.
acceleration is coming 0. If
Yes.
your acceleration is 0, that means the object is either stationary or moving at constant speed.
Constant, yes.
Now it's clear to you.
Oh, sir, now clear. Thank you, sir. Thank you very
Okay,
much.
you are most welcome. I like your questioning. You should ask me this way. Okay?
Okay,
Thank you
sir.
so
Thank
much for asking me. Now,
Bye bye, sir.
why bye bye? Taki, are
Time
you
up.
becoming over smart?
Sir,
No, sir.
sir, can I say something now?
Wait, raise your hand.
Sir, it is 11:55.
In your
Sir, I
clock,
can see that.
but standard green time is not 11:55.
Sir,
That's
3
why,
minutes
yeah, that's why I told you, Taki,
time.
you are becoming over
Evening.
smart day by day. Never do this again. Okay, if you don't like the class, you can leave, but don't distract us. Our 2 minutes gone. Okay. Now look, Basha, tell me.
Yes, sir. So I was saying that, sir, Taki didn't say a single word when you were explaining the notes. And like when his time's up, then he's saying time's up, sir.
I was copying everything.
But when sir
You
said to you,
don't
you
talk
didn't
too
answer.
much. Stop there. Now stop that. I understood everything.
Okay, sir.
Now friction.
Yes.
I told you that this note is uploaded already in your Google Classroom. I want you to read this friction, body at rest, then motion of vehicles. This much only. Before circular motion, you go through. All of you. This is your homework. I will ask in next class that who went through this and try to understand. These are very simple thing, and if you go through, you will understand it. Is
Okay,
it
sir.
clear? Only circular motion
Yes,
part
sir.
I have to explain because there are some tricky things and new ideas are there. That one you will not understand, but the other things you will understand. Okay,
Okay, sir.
you are matured enough to understand them. So
Yes,
our
we have
time's up
idea about
now.
this.
Now it's our time's up. Thank you all for
Yes, sir.
joining.
Sir, Assalamualaikum, sir.
We have tomorrow practical class, and on Sunday we have regular class, right?
Yes.
Yes,
Okay, attend in class regularly. You will be benefited, inshallah. Okay, Allah
Yes,
Hafiz.
sir.
okay, sir.
Sir.
Yes, sir. Okay, sir.